Okay, guys, we're live on YouTube. Stand by. 1. Hi, everybody. Welcome for joining us. This is the research vessel Falkor, operated by Schmidt Ocean Institute. You are joining us live in our control room. And we're just going to wait a couple minutes for some people to join in. Please feel free to let us know that you're here in our chat windows. We are going to have a brief section where our ROV pilot and our student opportunity is going to talk to you guys, and I'll introduce them in 1 minute. And then we're going to get a little bit of information tonight about the ROV SuBastian, and you'll get to see both some video footage as well as SuBastian on the aft deck, which will have some details. So if you can hold your questions till a little bit closer to the end, we'll then have the pilot answer those. So I'd like to introduce Jason Rodriguez and Liam Cook. Liam has been a student with us on this cruise, and he's been working with the ROV team. Jason is one of our ROV supervisors and pilots, and he's going to explain to us in detail about the ROV. My name is Deborah Smith. I'm a marine technician here on Falkor, and I'm going to be operating the video for this. So if you have any questions related to the ship, we are happy to help. So bear with us. This is our first live ship to shore like this. Please give your feedback. We'd love to hear it. And I'm going to have Jason take it away. If you give me 1 second, Jason, I'm going to bring up that video.
Which screen are you going to be playing
Again, everybody, thank you for joining us. If you're just joining on Facebook or YouTube, about the ROV and
6 fiber optic cables that allowed all the data transmission to come up and down with a 4K camera. Those 2 manipulators that you see right there, very strong and also very delicate. They can both pick up about 250 pounds in direction and deadlift 1,000 pounds. These bioboxes right here allow us to sample multiple different kind of organisms, corals, fish, and we can separate them into small containers or big containers. Here you're watching the oil down, and as long as we tight, that's that they do see. And this is another highlight of how good the suit is stored on deck. We have lots of straps on it so that when the boat's rolling around, it stays put and secured. All the yellow look like lemons. We call those lemon floats. We have to use those on the umbilical to allow a kind of a slack. We call it a catenary, and it makes like a big S. It allows the vessel to heave up and down, and instead of SuBastian getting yanked while we're trying to take samples or really nice shots, that slack goes up and down. It works very well. They would like. Where Debs is at, it's where she would actually be sitting there in the operations. She's going to be working all the media and answering all the questions. If it's questions that she can answer, we will direct them to the chief scientist who sits over here, and we try to do our best to answer them all. Sometimes we get a little bit busy, and apologize for that.
Thanks, Jason. Yeah, just a heads up. Sorry, guys, the stream has been kind of going in and out. I think it might be sort of stable. I apologize for that. It looks like it took our VSAT a little bit to settle in. As you can imagine, working at offshore quite a ways, the internet is not always as stable, as well as it can from time to time come in and out. So it looks like our feed has been holding in. I'm going to replay the video while Jason and Liam go out to the aft deck and actually give you a hands-on tour of the ROV SuBastian. I'm also going to show you a quick Google of where we are right now. So we're working off the coast of Western Australia. For those of you joining us in the United States or the UK or anywhere else in the world, I'm not exactly sure all of the time zones. We hope that you guys are being safe, staying home, watching this video. And I'm going to ask the guys to step out to the aft deck, and then we can give you a little quick actual insight, in-depth little tour of the ROV. So while they're gone, I will show you a quick video. Sorry for this. You're going to just get me for a minute. So we are working, like I said, off the west coast of Australia. And I'll show you a Google map here. Apologize for the uncropped of this. But we are currently working off this corner tip up the northwestern side. And I'll zoom in here so you can see where we've been working. So we have currently done quite a few ROV dives this trip. And you can see the canyon there that we zoomed into. And our dive from today was actually 342, and it was right on this ledge here, right in this part of the canyon. So when the ROV is not in the water, like it is not right now, we do a lot of mapping. We have 2 multi-beam sonars on board, and that allows us to get these high-resolution maps of the sea floor so that we can actually see where we want to put the ROV down. And this allows us to be able to accurately get an idea of what kind of ledges or outcrops that the vehicle might set down onto. And I'm going to quickly bring up the video. If you give me 1 second, everybody at home. Sorry, I apologize. This is our first one, and logistically it can be a little challenging to do multiple things at once. But I'm going to hopefully transfer you to our aft deck so you can see Sebastian. And here you go. Here is a live feed of the aft deck, and you can see Jason and Liam there in the corner. And we have our guest camera woman, Casey, helping us out tonight. Thank you, Casey. And Jason, it's over to you.
Roger that. Okay, so this is actually Sebastian without the 3D rendering. I'd like to first point out that we have an Artist at Sea program. So even if you're not into science and all the engineering and stuff that go on the Falkor, we have an Artist at Sea program, and some of the artists have been kind enough to actually paint some drawings for Sebastian. We got one on this side, that's our newest one. We have 2 more on this side. So there's always room for everybody. All right. And to Sebastian. Sebastian has 5 thrusters that propel. You got 2 thrusters right here that give you your forward, reverse, and axial movements to be able to rotate around and go forward. We also have a lateral thruster, which is hidden in the center of the sub, which is strategically put there so that we can make lateral movements without disrupting the visibility in the front of the sub. Most ROVs that you would find would have a thruster right here and also on the other side. And when you're up close to small critters and down deep, the sediment is really, really light. So any disruption, as you've probably seen in any of the live videos, takes a while for that to clear. So the more we have all the thrust going on in the back, the better it is. So I have 2 vertical thrusters, of course, for going up and down, and Sebastian is also different from other ROVs. We don't have a TMS system, so we actually have to fly the 4,500 meters all the way down, actively thrusting. It's a lot of wear and tear on them, but with the maintenance on them. We'll keep coming around. As I said earlier, the fiber optics that I was talking about, they come in right here. This orange cable right here would be what's inside of our umbilical. Our umbilical is the line that goes up there. The thing has a breaking strength of 20 tons. Also carries 6 fiber optic cables in it. The impressive stuff. But when it comes down, we take the armor off, and it comes in, and we terminate them in there. You actually only need 3 of the fiber optics. One is just for our 4K and 1080p camera, and then we have another one for 4 HD cameras, and then our final one does actually all the other electronics on the sub. So all your 232, 485 Ethernet conversions are going on with one fiber. Have multiple junction boxes for all the different sensors, O2 sensors, CTD, pH sensors, and then we also have spare ones that are used just for science upgrades. So when scientists come out and they have a new piece of kit, different kind of Raman spectrometers, mass spectrometers, we can attach it through this and use one of our extra fibers to get all of that data up to them. Coming around, these are Niskin bottles. These allow us to take water samples through the water column. So scientists will come up with depth or an area where they want to get water from that specific area. Like a CTD, they're more looking at going through a depth through the water column. With us, it's more how close you are to a well fall or a hydrothermal vent. They want to get close to it and get that water sample. And SuBastian used to only have 4, now we have 6. And with just a simple pull of a monkey's fist over here, this will go down and both sides capture the water right at that moment. And then when the scientists come up, they can use a valve and sterilized hoses and get just that pure water out of it and no contamination from any of the other water or oils or anything else that's going on. We have core tubes. We have the capability of putting 32 on if we were doing a massive boring project. Currently, we only have the 8. These work are it's pretty simple. We grab it with a manipulator. We try to go straight down, or depending on the way of the slope, going at an angle. And as we go in, this will open up, allowing the water to push out and not compact the soil. We get to the depth that the scientists want, it then will create a vacuum, and as we pull out, it will keep the sediment in there and in the layers as it was subsea. And then when it goes in here, there's a bung in here that actually makes a perfect seal and makes it stay the same all the way up to the water column. These are able to come all the way out to about here and retract all the way in. When we're just doing our camera work, we don't want them in the way of everything and the videos. Here, these are the bioboxes that I explained earlier. Again, we have the quad. So this one's set up for 4 different samples. This one over here is set up for 2. We actually have 2 massive ones in the back that allow us to even make this just 1. We have a divider in here that we can take out so that this would just be one big biobox for really big corals or sponges or really just anything that the scientists could possibly want. We also have all kinds of different things. The engineers on the vessel get very creative to make us different kinds of scoops. This is like our 8th version of making this scoop, and I don't know that it's going to change ever again because it's perfect. And it even has a big brother because we liked it so much. It is a bit ridiculous. And we also have bags, although it seems pretty crazy to have such a high-tech ROV to have rudimentary things. They work so good. Just a burlap sack, being able to scoop it through the mud. It'll let a lot of the fine stuff out in the water out, but it keeps all the precious stuff that the scientists need for their samples. We also have these new things. We call these, or actually I'm pretty sure y'all named it on YouTube. Y'all called this the kibosh, the kitchen brush of science. This is new to me as well. The scientists brought this on board for just this trip. We're actually using this to work with squids or octopus or starfish, and in an attempt to just agitate them, lightly brush them, that they will release either an arm or even just some of their suction cups, and then instead of bringing the animal up to the surface, we actually just need this, and we can put it in one of our small quivers, this one right here, which is another just piece of PVC and a plumbing bung, and it fits right inside, and then when they come back up to the surface, they have a pure sample. All right. Let's see. What have you found the most interesting part of SuBastian?
Helping the boys, sorting out, dividing up the bioboxes, helping out with some of the tool making, like the brushes. These were fun to make.
Yeah.
Small stuff, it's mainly to do with bioboxes or tools.
Right.
That's been the fun with SuBastian.
Cool. You've got to help a lot with launch and recovery, right?
Yes, I have. It's good fun.
Yeah, it's good fun. Is there anything that you're going to take away from working on SuBastian that has maybe changed your thought process of what you want to do in life, or?
Yeah, quite a bit.
Yeah.
I have no real plans for the future besides DF or Australian Defence Force.
Okay.
But coming on here and spending 2 weeks with the ROV team, seeing how it all runs, I think I might have found a new interest.
That's totally understandable. Do we have any questions, Debs? Do you want to answer some of that, and then I'll pick up afterwards? I mean, I can too. So.
You can answer it.
Okay, so this cruise is actually very diverse in what we're sampling, which makes me excited. Like, I like it when it's not just one thing we're focusing on. So, as I said before, we have core samples on, so we're taking blood samples or sediment samples. We have fish nets. We're actually going fishing with SuBastian and catching fish nets with the slurps. Doing shrimp, we're doing arthropods, we're doing corals, lots of mussels, and can never remember the one that we're in search for the most, but it's a monopoly. I'm gonna get in trouble for not knowing the name of it, but it's very important and it's really, really tiny, and we're gonna find it. I'm positive about that.
J-Rod, sorry, real quick, we have a question that's just come in. How quick does it take to get a sample? How quick does it take to get a sample?
It's dependent on the type of sample. Like this cruise alone is the first time we've gone actively hunting and trying to catch fish, and we've learned some lessons with it. So at first we were trying for a little bit and getting frustrated and it wasn't working, but then we realized if we just were patient and took our time with it, in about 15 minutes we were getting pretty consistently catching a fish, which we didn't even know was going to be possible. Core samples, depending on the sediment, it can take a minute, but if it's a kind of sediment that's not sticky and is real loose, and or I guess more coarse would be the proper term, they'll fall out sometimes, even though you have the suction going on the top. It's not packed in enough to actually hold it, and so it'll fall out. So that sometimes can take more time than we would like, but we strive to take a sample within 5 minutes. I would have to say that would be about the baseline that we would try to be able to, once we're done taking images, get in, take a sample within 5 minutes, have it stowed away, and get back on with science.
Awesome. Thank you so much for that. Our next question is from Johnny, and he wants to know, how long do the batteries last?
So, SuBastian does not run off any batteries. There are a couple of batteries. We do have a backup beacon, and that can last for 4 days, unless we're actively pinging it. And we also have some other beacons that have batteries, but SuBastian itself is supplied by the umbilical with 4,500 volts AC. The vessel gives to SuBastian, so in all reality, SuBastian can stay down as long as we have fuel on the vessel. Any more?
Yeah, we have one more. How many samples do you get in an expedition? Which I'm actually going to look up on our event logging system. So if you want
It's a lot.
yeah.
I mean, I can give a good guess. I would have to say...
Let's come up with some guesses, and I will come up with the actual answer so far. Stand by from me.
I would have to say, on the average 30-day cruise, 450. But that's also taken into account that some samples that we take are actually broken out into 10 different samples. Just the other day, we got a cuttlebone that was unique because normally cuttlebones float. We found one at the bottom of the ocean, and it had all these limpets all over it. So it was kind of a unique find.
So, I actually didn't hear what your guess was because I was trying to.
I said 450.
450.
What do you think?
I'd say about around the same, maybe 500.
So far on this expedition, and we're just only nearly, I think, halfway, 2/3 of the way there, we've done 11 ROV dives, and we have collected 1,348 samples, according to Sea-Log.
Wow.
So dive 332, our first one, was the most so far at 281. So, you know, the scientists get out here, they get really excited, they want everything, and I mean everything, and so we did 281 the first dive. So let's see, what are the other questions? Brian is asking, have we ever been caught in a storm, and how big were the waves?
Yes, the answer is yes. The last storm that the biggest storm I was in Samoa, and it wasn't, the swell was probably about 4 to 5 meters, but it was such a big, lazy swell that it was a little scary back here with the way trying to recover Sebastian, because if you look back here, I mean, this is right now actively us in pretty decent weather, but there's times to when you're standing right here and you're operating rope on the floats where you're coming up and you can't see the horizon anymore, and then you're coming down and water is shooting up through here. And yeah, we get some bad weather. We strive to run away from it because, I mean, there's really no reason to operate in bad weather, but sometimes one of the cruises.
A big swing.
Organisms, algae, all kinds of stuff to grow in and make a little community, and we can come back in 5-10 years and retrieve it and be able to study the changes that would happen within that amount of time. And as per my understanding, the scientist group would like to come back in 5 years, hopefully with Falkor, and retrieve them all.
Oh, cool. That would be amazing. I apologize to everybody at home. I know our feed keeps freezing. It looks like we have some streaming issues. Hang in there with us. Hopefully it'll get better. James has a question. Hi, James. Thank you for joining us every day during our dives.
Mr. Driscoll, hello.
We have a few who join us every day. For those of you who don't know, we live feed our ROV dives daily, almost daily, and you can find it on YouTube and Facebook. Our website, schmidtocean.org, usually tells you if we're live or not. Mr. Driscoll has a question. Every now and then you find a litter or junk left by people. What is the weirdest thing you have seen?
Man, as soon as you asked the question, I went back to the frozen balloon in Costa Rica. It was just brought it to a different light, you know, like, I mean, I have young kids, and you want to give them balloons and you want them to be happy, but then when you see it still had the frozen on it, and so you know it's not down there that long, but it's just like, it's simple things that we do, letting a balloon go, that can cause so much havoc to the oceans. And once you see it, you don't know, you just assume it just goes away somewhere else, and that one always stands out to me. There's been some worse ones, but it just more hit home for me. What about you, Dibs?
Yeah, I think I wasn't on board for the balloon, but I think the balloon really does it for me. I think more and more balloons make me kind of cringe. You know, as a kid, you really love them. They're cool. I can't say I've never bought a balloon or used it, but I think seeing it live in color on the seafloor definitely brings home how much impact humans have to the deep ocean. And I mean really deep ocean, places that you just would never expect trash to be. And really next to all of these amazing living creatures. The next question is from Kevin. He's asking, how do you pick dive locations? So that's a combination of a lot of things. It's what can be feasible for the ROV. And Jason, you can talk a little bit about how you set up the vessel and vehicle. I can talk from the multi-beam end of it. Usually after mapping at night, you sit down with the chief scientist or whoever's in charge of picking dive sites, and you look at the terrain, you look at the multi-beam, and you sort of pick. And I think a lot of it depends on what they're looking for. So for corals, we're typically looking for terrain that might have high flow, so high current, and the corals like to stick out and feed off of that. And so there's always a bit of multiple kind of factors that go into that. And then usually they want something that has a bit of rocky edge so that things attach to it. When you're looking for more biological samples, you might want a more open terrain and flat and sandy, and so you can usually tell that from the multi-beam as well. And then Jason, if you want to talk about what is one of the most challenging things about when a scientist picks an ROV dive location and then you guys have to fly the vehicle there.
Yes, so the biggest aspect is, as Deb said, through the night they do all this mapping, all this discussion of this amazing spot that they want to dive on. And then when we get there, the way that the currents are working on the surface really affects the way that we launch SuBastian, because we launch off the back. And so we don't want to be working downhill in case the vessel has an issue and they have a runoff, then they'd be dragging us up a hill. So we need to be set up to where any shallow water is in front of us and the vessel behind us. We can work with that because we have a 180-degree working window, but currents don't always work in your favor, and so sometimes we have to change a dive plan completely from the way it was thought through the night, just because the current is 45 degrees out from optimal. Fortunate, but having a free flyer and the way that we have to drop our umbilical below us, if it were to get caught up on some kind of a ridge and snagged, SuBastian would be done and really hard to recover.
Okay, and our next question is from Maya as well. How deep do you usually go?
I would have to say on average, we go down to 2,000 meters on average for the 2 years I've been here. As of late, it's been getting deeper and deeper. On average, it would be 2,000 meters.
Okay, guys at home, we probably have about 5 more minutes, maybe a little less. Any last minute questions? I know the feed has been kind of coming in and out. I think we just got a boost from our electronics technical officer, ATO. He is trying to keep the stream going and happy. I'm sure everybody else trying to talk to home on Facebook isn't happy, but we tend to move the bandwidth around on the ship quite a bit. So that we can do these calls to you at home, as well as people can still get email and connect with family. The pictures you're seeing on the screen right now, I've got a little window inset for the guys on the aft deck, are J-Rod's favorite. So one of the things he does every evening typically is look for some really cool pictures or video of things that have happened throughout the day. We also have a multimedia correspondent on board, so all of those videos that you see that come out are weekly videos, are highlight videos. We have somebody on board just to tell the story of the expedition as well. So I think, unless anybody else has any last minute questions, what do you think, guys? Anything else you think we've missed?
Do you have any questions, Liam? You're leaving in a couple of days. Is there anything that you don't know about SuBastian that you would like to know, or just the Falkor in general?
Can I trade from the science team to the ROV for the second leg?
I'd say yes, but it's not my call.
True.
One final question from Kevin. How do you track the position of the ROV from the ship?
That's a very good question. So I'll show you the back beacon real quick before you explain the USBL pole dip. So we have two beacons. There's one on the front. Where it's at is not very good for the way that the lighting is right now. This is a smaller one. This is the battery powered one that I was explaining earlier. This is a beacon that can acoustically talk to the vessel and actually talks to Debs and her department, and she can explain that a little bit more into precision, except for one last little thing that Sebastian used in correspondence with that. We have what you call a DVL. DVL is kind of like an ADCP. It again is also like a sonar. It's on the bottom of our sub, and it has 4 beams that go out in different angles. So 2 are going to go out that way, 2 come out this way. It uses that to find a average altitude off the seafloor. Also can track the ROV moving over the land and can get your speed over ground. It also has a gyro on the inside that can, it's an accelerometer, so it can also know precisely how much you're moving with the delay in USBL fixes that Debs will talk about.
So USBL stands for ultra short baseline, and essentially that beacon on the ROV sends a signal to a transponder we have on the ship. So basically we have a pole that extends down through the center of the ship, and the 2 communicate. And so basically it says, hey, where are you? And the other thing says, hey, I'm over here. And so the 2 throughout the entire dive communicate, but unlike some devices where they communicate just through the water, we actually have a communication link, what's called responder mode, through the umbilical cable. So we have almost instant real-time communication of where that location is. So that allows us to really keep really close contact with the ROV and be able to track it. And so we are able to also log all of that navigation data, and we're actually able to live feed it into our multi-beam data in 3 dimensions. And so we can kind of see where the vehicle is on our maps as well. And it allows us to really keep track. The DVL, as Jason mentioned, is a Doppler velocity log. And so what it's doing is actually measuring the motion or speed of the vehicle over the water. And so he mentioned an ADCP, which is an acoustic Doppler current profiler, and that actually measures current of water. So we have an instrument on the ship that the ROV team uses to be able to see what the current, speed, and direction are. And so the combination of all of that really help us be able to put the ROV in a very specific location as well as track where it is. So there's 2 questions, 1 statement, 1 question. Liam, your mom says hi. And 2...
Hi, Liam, Mom.
Don't say hi to her.
He'll be home soon, Mom. And the other one...
Wave hi to your mom.
The other one, which is really great question, is what advice do you have for young kids who want to get involved in your line of work? So 1... Jason, if you could give the perspective of a little bit of what your background is and what brought you to Falkor. And then Liam, I'd love for you to also tell students and other kids how you got the opportunity to be on Falkor. Where did you hear about it and how did you apply? You guys can fight over who goes first.
You want to go first? You want me to go first? Okay. So for me, I've always been interested in electronics, taking things apart, putting things back together. I mean, that was me from a kid and still do it today. Take things apart in here all the time and make stuff out of it. I was in the Navy for 8 years. I worked as an aviation electronic technician, and I also was an operator on a plane. So not only did I fix the position that I worked at, but I also operated it, which gives you a little bit more of a ownership to the gear that you're working on, and also makes you work on different types. You're not just doing one thing. So a big portion of being an ROV pilot and technician is that you don't need to be good just one thing, great at one thing. You just need to know a little bit about a lot of stuff. ROV is made out of hydraulics, electronic, electrical, software, coding, all kinds of different aspects. Oh, and I am not master of any of them. I would say that electronics would be my my main discipline, but I have to know a little bit about all of them, and we are lucky enough to have a support group on the shore side with a mechanical engineer and an electronic engineer that when it gets really depth, they help us through it, and they provide us with all the drawings and that we could need. Going through school, I wouldn't say there's a path that you have to take to get to ROVs. Everyone that I've worked with as an ROV pilot, different background, different schooling, and it was possible for everybody. So I would say if you have an interest in it, just be a sponge and learn anything you can, because I still do it out here. I'm learning so much about science and biology and chemistry that it's so much fun. Like, it's such a joy to work here. To you, sir.
How I got out here was the head scientist, Lisa and Nerida, contacted one of my coordinators for a program I am enrolled in. And the coordinator's name is Helen Bell. Thank her for getting me out here. They asked if they had any Aboriginal or Indigenous students of Australia if they wanted to spend 2 weeks out in a science lab or on the Falkor. I put my hand up and got selected for it by sheer dumb luck. I was also pushed by my parents to apply heavily.
Good job, Mom.
Good job, Mom. We like them. Did really good work.
Once I got out here, spent the first couple of days with the science team until I found what was sitting on the back of the ship. So I joined the ROV boys. I got out here by sheer dumb luck, practically, but the best 2 weeks ever.
I feel the same way. I feel like I got into ROVs by sheer dumb luck. So I mean, once you go ROV, you never go back down. Right?
Watch how it feels.
Any more questions, Debs?
Sorry, I think we are mostly done. I'm going to answer this last one. Actually, we do have one. Adriana Rodriguez. How do you decide what specimens to sample?
So that's mainly up to the chief scientist and the rest of the scientists on board. And they are always telling us what to sample, and more importantly, how much to sample. It's not always the case that we have to take a full specimen. Australia is different in the waters that we're working in right now, that you may see that SuBastian's taking bigger and more samples than what we normally would, but it's because we've worked in the past, ROVs have been before, and it's been documented, so they only need to get a small little snippet to just see the changes of the samples from past. Here in Australia, they haven't had the opportunity to have an ROV that can go down as deep, have these corals and fish cataloged, and from the depth that weren't towed and destroyed coming up. And SuBastian gives them the opportunity to get full samples to be able to put into the museums, and so that people can study a beautiful full sample and not just go off of images.
Great. Okay, I think we are done for the day. We wanted to thank everybody for joining us. And do you guys have any last minute comments?
No, I do not. Thank you guys for joining. Hope we answered all your questions.
Great. Yes, thank you very much, everybody, for joining us. This is the research vessel Falkor, Schmidt Ocean Institute. Remember, you can join us almost nearly daily watching live ROV dives. We are in Western Australia, so that might be a bit of the middle of the night, but you can always go back on YouTube and Facebook and watch the dives live, watch the dives again. And if you have questions, please feel free to reach out to us. You can get us in the live feeds, or you can send messages on Facebook, and we will try to answer those. And we are going to do a series of these live ship to shores, so our next one will be Tuesday night. We are same time, and we are going to be joined by our chief scientist and co-PI, Nerida Wilson, Dr. Nerida Wilson, and Lisa. And you can hear all about this cruise and what we found so far and what the plan is for the rest of the cruise. So please join us Tuesday, same time. Thanks everybody for coming. Thanks guys.
Bye-bye.